Heterocyclic compounds are widely distributed in nature, which are essential to life. Genetic material DNA is also composed of heterocyclic bases like pyrimidines and purines. A large number of heterocyclic compounds, both synthetic and natural, are pharmacologically active and are in clinical use. Several heterocyclic compounds have applications in agriculture also, as a insecticide, fungicide, herbicides, pesticides. They also find applications as sensitizers, developers, antioxidants, copolymers. So these are the heterocyclic compounds which are having many uses. Hi, I am Amit Lunkad. In this video, we discuss about the what is meaning of heterocyclic compounds and nomenclature of these heterocyclic compounds. Let's begin with the meaning of heterocyclic compound. A heterocyclic compound is the cyclic compound containing one or more heteroatom in its cycle. Heteroatom means an atom other than carbon and hydrogen. The most common heteroatom present are nitrogen, oxygen, sulfur. Here is the structure of benzene ring, and if you see this, it just having a carbon and hydrogen. But in this structure with carbon hydrogen it having a nitrogen, and this nitrogen we call as a heteroatom. So this compound is called as a heterocyclic compound, and this is the structure of pyridine. So these are about the meaning of heterocyclic compound. Heteroatom which are present in a cyclic ring with carbon and hydrogen. Now about the nomenclature which are given to this heterocyclic compound. The heterocycles are named by using revised rules of Hantzsch-Widman nomenclature system. Here we discuss about the monocyclic containing single heteroatom, and we use some rules for this. First is there is a heterocyclic system is named by combining one or more prefixes for the heteroatoms with the stem. So first is about combination of these prefixes with stem. So what is prefix? The prefixes indicate the heteroatom present in the heterocyclic system, and stem means the which is used to indicate the size of the ring and the saturation or unsaturation in the heterocyclic system. So stem means this indicate the size of ring, means whether it is a 3-member ring, 4-member, 5-member, 6-member and so on. So we combine this prefix and stem to form a name to this heterocyclic ring. So first is about the prefixes for the different heteroatoms which are in preferential order. So here is the heteroatom like oxygen, sulfur, nitrogen and phosphorus. So which are the prefixes we use for this? So if your ring having oxygen, so which having a symbol O and it having a valency of 2, so we use prefix oxa. If sulfur is present, the symbol is S and it having a valency 2, we use prefix thia. For nitrogen, symbol is N and which having a 3 valency, and we use aza as a prefix. And for phosphorus, the symbol is P, it having a valency of 3, and we use the prefix phospha. So you have to remember this prefix for the heteroatom for oxygen, sulfur, nitrogen and phosphorus. Most of the heterocyclic compounds having a oxygen, sulfur and nitrogen. So remember, for oxygen oxa, for sulfur thia, for nitrogen aza. Now here we use stems for 3 to 10 member heterocyclic compound, and accordingly whether these are saturated or unsaturated, whether they contains nitrogen or without nitrogen. Like here, if the ring size is 3, then if it is unsaturated one and with nitrogen, then we use the stem II. IRINE, iron. And if it is unsaturated 3-member ring without nitrogen, we use the same irene. But if it is saturated with nitrogen, then we use we use same iridine, and without nitrogen saturated ring we use irene. Like for 4-member, if it is unsaturated with nitrogen, ETE, stem we use, and unsaturated 4-member ring without nitrogen, stem is ET. But if the 4-member ring which is completely saturated with nitrogen, then we use stem etidine, and without nitrogen 4-member ring saturated one, we use the stem ethane. Like if it is a 5-member ring which is completely unsaturated and with nitrogen, then we use stem OLE. Both for without nitrogen, the 5-member ring, also we use the same OLE. But if this 5-member ring which is completely saturated with nitrogen, then we use olidine, and without nitrogen 5-member saturated ring we use the same olane. Like for 6-member ring, INE, IN for unsaturated compound. For the 6-member ring, if it is saturated without nitrogen, we use the same ANE, and no more any stem we use for the with nitrogen. So these are the, according to ring size and the nature of the ring, whether saturated and unsaturated, we use this same. So you have to remember this. So to know this, we have some examples. Like here is this heterocyclic ring, as it contains a carbon, hydrogen, and with this oxygen. So oxygen is a heteroatom. So as it is having a oxygen, so for oxygen we use the prefix oxa. Now here it is a completely saturated ring and without nitrogen. So which stem we use? So look here, it is a 3-member, ring size is 3, and which is completely saturated one and without nitrogen. So we use the stem irene. So just give it plus irene. So name of this compound or name of this heterocyclic ring is oxyrane. To know much more about this, we take second example. Like here it is a 3-member ring but having a heteroatom nitrogen. For nitrogen we use the prefix aza. So which stem we use for this? So here it is a ring size is 3, it is completely saturated one and with nitrogen. So with nitrogen saturated ring we use the stem iridine. So just put it, so plus iridine. So name of the compound is aziridine. So with these two examples, you will also know that here is the oxa, but here is the A is drop. Here is aza, but A is drop. So while giving this or combining this, you have to remember, if the stem begins with the vowel, the terminal letter A of the prefix is drop. Yes, here the stem is starting with vowel I, so we drop this A of the prefix, and that's why the name is OXIRANE, oxyrane. Same for this aziridine. We drop this A of the prefix because the stem is starting with vowel. Now next example is, now here it is the 3-member, ring size is 3 and it is unsaturated one and it contains nitrogen. Yes, obvious, for nitrogen heteroatom we use aza. Then for which unsaturated 3 ring size, which stem we use? So look here, the ring size is 3, it is unsaturated one with nitrogen. So we use IRINE, irene. So just put it here plus irene. So name is, yes, it is stem is started with the vowel, so you have to drop this A. So name is azurine. Same for the next one. It is a 4-member ring which is completely saturated one. So look here, it is a 4-member. Now it is saturated one and with nitrogen. So it is ethidine. You have to use this stem ethidine. So for nitrogen, aza plus ethidine. So name is azitidine. Next is here, it is a ring size is 5 and having heteroatom oxygen. So for heteroatom oxygen, oxa. Now here it is a 5-member ring. So it is a 5-member or ring size is 5 and it is a completely saturated one without nitrogen. So OLANE. Okay, so you have to plus olane. So the name is oxolane. Next is the here the 1, 2, 3, 4, 5, 6, 7. Ring size is 7 and it is unsaturated one with nitrogen. For nitrogen heteroatom, put the prefix aza. Now here we see it is a ring size is 7 and which is unsaturated one with nitrogen. So we use the stem epine. So just write it, and it starts with the stem starts with the vowel, so drop this A. So name is azepine. Same for here, it is oxygen, so it is oxapine. So these are the example. Here we use the combination of prefix with stem and we have given the name for that particular heterocyclic ring. Moving to the next point, which is the presence of identical heteroatoms, means multiplicity of heteroatom. So your heterocyclic ring contains more identical heteroatoms. So what to do? So when 2 or more heteroatoms of the same type are present in a ring, the prefixes di, tri, tetra, etc. are used and placed before the prefix used for the heteroatom. Like di means it indicates the 2 heteroatoms are present which are identical. If 3 are present, then tri. 4 are present, then we use tetra. So let's take an example. Here is the example in which there are the 2 identical heteroatoms are present and which are oxygen. Just now we have seen one example in which the 5-member ring which is saturated and with oxygen, the name we use is a oxolone. But here there is a presence of 2 oxygen or 2 heteroatoms, so we use the before that we use this prefix di. So it is the dioxolone. And here we have given the 1, 3 means it indicate the numbering to which they are present. This point we discuss later on. Let's move with the second example. Now here it is a 5-member unsaturated ring having how many nitrogen? 1, 2, 3. So name is triazole. It having a nitrogen, so aza, and it is as it is 5-member ring we use OLE. So name is azole, but as it contains the 3 nitrogen we use prefix tri. So the position is 1, 2, 3, 4. So 1, 2, 4 triazole. Now here is the next one. It is a example in which name is diazine, 1, 3 diazine, and the common name is pyrimidine. So this is the second point in which we have seen the name for the heterocyclic ring, and if it having a 2 identical heteroatom, then how to give the name for this. Now moving to the next point. Suppose there are the 2 different heteroatoms are present, then what to do? So in that case, when 2 or more different heteroatoms are present in the same ring, the prefixes of heteroatoms are combined in order of their appearance. Like we have seen the prefixes in preferential order, like the first preference is given to oxygen, then for sulfur oxygen oxa, for sulfur thia and for nitrogen aza. So you have to remember OSN, which is the preferential order. Here is the example in which it having a 5-member unsaturated ring containing sulfur and nitrogen. So in that case we give the preference to sulfur. So first of all, for sulfur we use thia, for nitrogen aza, and as it is 5-member ring we use stem OLE. So combinedly it is thiazole. It is thiazole. Okay, here we this A letter we drop, and also this A letter we drop, because in both it starts with the vowel. So the name is thiazole, and as we give the preference to sulfur, so it having a number 1. So 1, 2, 3. This point we discuss later on. Let's see the second example in which it having oxygen and nitrogen heteroatom. So which one having preference? Obvious, to the oxygen. So write the prefix firstly for oxygen as oxa, then for nitrogen aza, and as it is 6-member ring, the stem we use is INE. So combinedly the name is oxazine, and it is a 1,4-oxazine. So this is the applicable, or we use this when it having a presence of different heteroatoms in a ring. Now next point is numbering. So if it having one heteroatom, then the numbering in the ring starts from the heteroatom and giving the position, and proceeds in such a way as to give the lowest possible locant to the substituent if it have. Like here is, just take example, it is a ring having nitrogen heteroatom, so we give the numbering from the nitrogen. So first is to the nitrogen, then accordingly you have to give the number. Now second example, this is the pyridine. Now second example, in that case it is a pyridine ring but it having a substituent. So from where, obviously you have to give the number 1 to this nitrogen, and where to give second number, whether to the clockwise or anti-clockwise manner. So you have to choose, you have to give the lowest locant to the substituent. Okay, so if you give from this, then it is having second, so it is a preferable. So 1, then 2, 3, 4, 5, 6. So name for this is 2,5-dimethyl pyridine. Getting? Now next is with 2 or more identical heteroatoms if the ring it have. When 2 or more identical heteroatoms are present in a ring, the ring is numbered in such a way that the heteroatoms are assigned the lowest possible set of number locants. Now here is the example. So if you see this, so the first is given to the heteroatom, and accordingly you have to give the numbering, but to this it having a lowest possible set of number to the another heteroatom. So here is the preferable 1, 2, 3, and here is the 1, 2, 3, 4, 5. So we have given the number. So which one is correct? So in case of first, it having a 1, 3 number given to the heteroatom, and in this set the 1, 4 number is given to heteroatom. So which one is correct one? So obviously the first one is correct and this is incorrect. Now take another example. Here is the numbering is given. Suppose I given as to this nitrogen 1, then 2, 3, 4, and if also I give this 1, 2, 3, 4. So if I give the numbering to this, then the heteroatom having a 1, 3, 4 numbering, and in this set it having 1, 2, 4. So from that, which one is correct? Obvious, this one is correct and this is incorrect numbering. So remember this, when two or more identical heteroatoms are present, then you have to give the numbering in such a way that the heteroatoms are assigned the lowest possible set of number locands. Now, if it having two or more different heteroatoms, when heterocyclic ring contains two or more different heteroatoms, the numbering starts from the highest preference as oxygen, sulfur, nitrogen. The remaining heteroatoms are given the lowest number locant. Just take example. Here is the heterocyclic ring which having a two different heteroatom. So preference is to the sulfur. So put the first number to sulfur, and then where to give second number, whether to this or to this carbon. So obvious to this carbon, because if you give this second, then this nitrogen having lowest locant. So 2, 3, 4, 5. This is the 1,3-thiazole. Here is the another example, and we give the first priority to oxygen, then to lowest is to the second heteroatom. So 1, then 2, 3, 4, 5, and it is a oxazole, and give the position of this. So we have to put number 1, 3 oxazole. So indicate at first and third position the heteroatoms are present, and first to the oxygen and third to the nitrogen. Then here is the another example, and which is the numbering and name is oxathiolone, and here is the numbering 1. Obvious, we put the second to this nitrogen, not 2 here, because if you give the 2 number here, then it having a highest number, but if you put the second number, then it having a lowest number locants. So name is the 1,2,4-thiadiazole. Now here is the next is presence of saturated atom, which can be indicated hydrogen. So when a heterocyclic ring with maximum number of non-cumulative double bonds contains a saturated atom, its position is given the lowest possible locant and is numerically indicated by a italic capital H before the name of heterocyclic ring system. So here is the example, like in this ring the sulfur and nitrogen heteroatoms are present, and we have seen the previous rules for this. So you have to put first number to this sulfur, and as it contains it is unsaturated ring, but it is a non-cumulative double bonds are present. So here is the more hydrogens are present. Here is the CS2. So you have to give the second position to this carbon. So first, second, third, 4, 5, 6. So to the second position the hydrogen is present. So you have to written it in italic and give the number. So it is 2H, 1,4-thiazine. Same the case for here. To this nitrogen it having a hydrogen, and the numbering is obvious 1, 2, 3, 4. So you give 1, 2, 3, 4 to clockwise or anti-clockwise, doesn't matter, because in both the case the nitrogen having a 4 number. So to the 4 hydrogen is present, so write as a 4H, 1,4-thiazine. So these are all about the heterocyclic compound and numbering to the heterocyclic ring. Hope all of you getting this. Thank you and happy learning.